Assalamu alaikum students. Today our topic is related to the phase angle in LCR circuit. That is, what is the net phase angle in case of a circuit where we are having the L, that is the inductor, the capacitor and the resistor. As we are aware, we have lastly read about that in case of what? In case of the resistor, the voltage and current, they are in phase. And in case of this very inductor, the voltage is leading the current by an angle of pi by 2. I have shown like this, and in case of resistor both are in the same direction. But in case of the capacitor, it is the current which leads by an angle of pi by 2, or you can say the voltage lags by an angle of pi by 2. So we will now see we are having an inductor dominating circuit. That is, once we are having an inductor dominating circuit, that means VL will be much more than as compared to VC in magnitude. So consider a circuit as shown in the figure where we are having a resistor of resistance R, inductor of inductance L, and capacitor of capacitance C. All are in the series. This is a series circuit, not a parallel. If we will say V equals to V naught sine omega t, this will be the amount of current alternating voltage across LCR circuit. As the all three are connected in series, so one is the instruments are connected in series, one is the appliances are connected in series, device is connected in series, then same current flows through them. That is, whatever may be the current here, same is here, same is here. The potential drop across the three will be totally different because they are connected in series. So we will see in case of the resistor we will say of resistance R, we'll say VR equals to IR, where I and R they are in phase, and we will see this is a potential drop in this very resistor. Now potential drop across L, that is the inductor, that will be how much? VL equals to I XL. I is the current and XL is the inductive reactance. That is, whatever is the function of resistance in case of a resistor, same is the function of what? Reactance, inductive reactance in case of the inductor. And here you have to remember it is the current which it is the voltage which leads the current by an angle of pi by 2. And in case of the capacitor, potential drop across C, how much will be that? That will be VC equals to I XC. Again, XC is called as the capacitive reactance, has the same function in case of a capacitor as is having the resistance in case of what? In case of the uh, resistor. So VC, that is the voltage that lags by a value of pi by 2, by a phase of pi by 2, than the current. Now we will show these very things. This is VR in case of the resistor. Now we are having the inductor dominating circuit. Once we are having inductor dominating circuit, this is the VL and this is VC. Why I have shown from this very point to this very point a small amount of VC? Because it is inductor dominating circuit. So net voltage will be in the upward direction, and let me show that up to this very point this will be VL minus VC. So now up to this very this is VL minus VC, this is VR, and we are going to complete this very, you will say, a rectangular parallelogram, and this will give us the net resultant of the two, what? VL and VC, VL minus VC, and VR we will get the net of two. Since V and VC they are in opposite direction, so their resultant, what is the angle between VL minus VL and VC? That is 180. So VL minus VC, it is represented by, if I will say it is O, It is A, O A B and C. This represents what? This represents VR minus VC. The resultant of now VR, now we have it becomes as a parallelogram law vector. The resultant of this VR and this VL minus VC can be calculated by parallelogram law vectors. So this resultant V is obtained by, as we are aware, we are having the formula R equals to under root of the magnitude of 1, that is the A vector square plus B vector square plus 2AB cos of theta. Now the two vectors here, that is one you will say the VR, although it's not a vector, but we are going to represent it from the vector form. They are having an angle of 90 degree. VR and VL minus VC. So here V equals to under root of, first it will be the VR whole square plus VL minus VC whole square plus 2AB, 2, instead of A we are having VR, instead of B we are having VL minus VC into cos of 90 degree, because the angle between VL minus VC and VR, that is this very 90, and this is the resultant, that is the V. Now cos 90, that is how much? That is 0. Then this very term whole vanishes. What resides inside is, that is V equals to under root of, it is VR square plus VL minus VC ka whole square. Now if I will place the values of them, then VR is equals to under root of, instead of VR we will place I R whole square plus of, instead of VL and VL it is I XL minus I XC whole square. So I and I, it will come out as an I, it is I square and it will come out as an I. So V equals to I times of, it will be R square plus XL minus XC whole square. And now if I will place V over I, that equals to what? Under root of R square plus XL minus XC whole square. But V by I, that equals to Z, which is called as the impedance, where Z is the effective opposition of it. It is called as the impedance. What is the difference between impedance and reactance? Reactance, resistance, whether capacitive reactance, inductive reactance, and impedance means the portion offered by LCR circuit. Impedance means the opposition offered by LCR circuit, you have to remember, and this is called as the impedance, denoted by Z. Now we will be having the second part of this very lecture in we will be having the second part of this very lecture next time. Till then, Allah Hafiz.